Right, so part B of this question is asking about the possible values of mu. And mu is associated, so f is equal to mu r. We know f is equal to mu r. And so we're going to be looking at the parallel to the slope equation. So parallel to the slope, I've got 30 cos. I'm going to go do the positive one first. 30 cos alpha minus 20 sine alpha minus f. And what this is the resultant force going parallel to the slope. The resultant force going parallel to the slope. We know that the particle is moving up the inclined plane, but we don't know if it's moving up at a constant velocity or if it's accelerating. So this will either be greater than 0 or it could be equal to 0 if the velocity was constant. So we know that that's true. So I'm going to sub in my cos alpha as 12 over 13, my sine alpha as 5 over 13, and f as mu r. And we know that r was 30, so it's going to be 30 mu greater than or equal to 0. Now I'm just rearranging to work out mu, and you rearrange that, you should get 30 mu is less than or equal to, so that's 360, so that's 260 over 13, which is 20 over 13. And divided by 30, you'll get mu is less than or equal to 2/3. So that's your range of values of mu. Part C, we're told that the horizontal force is now removed. The particle continues to slide up the plane until it comes to instantaneous rest, and then it slides back down the plane. We know that mu is 1/3. Find the acceleration as it slides down the plane. Okay, so we've got a new diagram. The situation has changed. The horizontal force is now removed. We're only interested in when it slides down the plane. So when it's sliding down the plane, we know that the friction will be going up the plane. There's always still going to be a reaction. That reaction might have changed because, well, definitely will have changed because the horizontal force would have had an impact on the reaction. And then we've got our 20 Newton force going down the slope, going into the slope like that, vertically down. And again, if this is alpha, then this here angle will automatically be alpha. And so the one opposite is 20 sine alpha, and the one adjacent to it, therefore, is going to be 20 cos alpha. We've got f going up the slope and r going perpendicular, right? So if we resolve perpendicular to the slope first, this will enable us to find out what r is. So we've got r going perpendicular to the slope, we've got 20 cos alpha, but cos alpha we know was 12 over 13. And that's equal to 0, so r is equal to 240 over 13. Then we've got r going parallel to the slope, the resultant force parallel to the slope. I'm actually going to take, it doesn't matter, like you'll just have more negatives if you take upwards as positive, so I'm going to take downwards as positive, and that's because we know it's accelerating down the slope. If I take downwards as positive, I've got the 20 sine alpha, which is 20 times 5 over 30, which is coming down the slope. Then you've got the friction going up the slope. And we know, because it's accelerating, that this is our resultant force, and that's going to be equal to ma. So ma, let's just write that for a second. Okay, so that's 100 over 13 minus f is equal to 1/3 r. We were told in the question that mu was 1/3, so I can put 1/3, and then I've worked out my r, which was 240 over 13, and that's equal to now the m. We know that the weight is 20, but remember weight is equal to mg, so therefore the mass is equal to 20 over g. Now that we know that the mass is 20 over g, we can plug that into here and a, and then rearrange. So we've got 100 over 13 minus 80 over 13, so that's 20 over 13 divided by 20, so you're going to get g over 13 as your acceleration. You shouldn't give your answer like that, so let's work that out in the calculator, and the acceleration comes out as 0.75 meters per second.